We have here x to the negative 4, y to the negative 8, all over x squared, y to the 5th. Okay? So, direction says to simplify. Use positive exponents. Use positive exponents to write the answers. Now, even if it didn't remind you to write the to use positive exponents to write the answer, it's understood because you have that negative exponent property that you're not to leave your answers with negative exponents. Okay, so for question 1, x to the negative 4, y to the negative 8, all over x squared, y to the 5th. Well, we're going to use the negative exponent property, but we're only allowed to take the reciprocal of expressions that have negative exponents. So my question to you is, will we take the reciprocal of x squared, y to the 5th? No. That stays in the denominator. But what will we take the reciprocal to? X to the negative 4 is going to go to the denominator. The base stays the same. The exponent becomes positive. What else? Y to the negative 8. That goes to the denominator. Your denominator, base stays the same. The 8 becomes positive. But what's in the numerator? 1. What are we going to do to the exponents now? Add. Thank you. Yes. We have 1 over x to the 6th, y to the 13th power. Number 2. 8. X to the negative 5, y, z to the negative 6, all over 4, x to the 4th, y, z. Okay?
The y's cancel out?
Yeah, the y's will cancel out. Yes, ma'am. Also, now let me just circle right now. The x to the negative 5, z to the negative 6, that's going to go to the denominator. Reduce 8 over 4.
In the morning.
Which is 2. So in the numerator we have 2. And then we said x to the negative 5
You not eating?
is going to go to the denominator. And base stays
not
the
eating
same,
anymore?
exponent becomes positive.
Oh, okay.
Z to the negative 6 goes to the denominator. Base stays the same, the exponent of 6 becomes positive. And then we also have x to the 4th, z. Our answer, 2 all over x to the
9.
z to the, thank you. Number 3. This is the quantity of x to the negative 6, y to the negative 2, all over a to the negative 2, and then all of that is being raised to the negative 2 power.
They're all in the same spots.
They're all going to stand, just hold on, because they will stay where it belongs, because when we take this negative 2 and we distribute to each factor, yes, everything becomes positive. Every factor becomes positive. Now, if you want to see the work, you're saying x to the negative 6 times negative 2, y to the negative 2 times negative 2. This is what you're doing. All over a to the negative 2 times negative 2. So yes, our exponents become positive. So we have what? X to the 12th, y to the 4th, all over a to the 4th. All right. Any questions with the first 3 that we've done? Okay. So don't write too big because we have some more room on this paper here. Number 4. We have here x to the 4th over y to the negative 6, and then all of that is being raised to the negative 6 power. Take the exponent of negative 4, we're going to distribute. To each factor, you're saying x to the 4th times negative 6 all over y to the negative 6 times negative 6. So that it becomes what? X to the negative 24 all over y to the positive 36. But we're not done. Why is that?
You got a negative on the bottom on the top.
Yes.
That move to the bottom.
Yes, sir. Oh, gosh. So, we're right there, but we're not finished. It says make sure we write our answer with positive exponents. So we're going to take the reciprocal of x to the negative 24. Yes, it will go to the denominator. Will we take the reciprocal of y to the 36 power? Yes or no?
No.
No. Why? W-H-Y, question mark. Because the power is positive, yes. Okay? So, x to the 24th, y to the 36th, and what's in the numerator?
1.
Let's see. We have here, oh, this is a good one. 2 x to the negative 6 all over y to the negative 3, and then all of this is raised to the negative 3rd power. This is a really good one. Take the exponent of negative 3, and we're going to distribute that to each factor. Each. Okay. Now, I'm not going to show the times when we take the negative 3 and we have power to a power. I'm just going to write the answer. Okay. I've been showing it in the previous examples, but I want you to understand that we are going to multiply this x to the negative 6 raised to the negative 3rd power. Is that x? I put y. So that x to the negative 6 raised to the negative 3rd power becomes what? X to the 18th. All over y to the negative 3 to the negative 3rd power. 9. Okay? So, there's only one factor that we need to take the reciprocal of because the exponent is negative. Which factor is that? 2 raised to the negative 3rd power, because base x has a positive exponent and base y has a positive exponent. But this base 2, the exponent is negative. Take the reciprocal and bring it to the denominator. X to the 18th all over 2 cubed y to the 9th, and then tell me what is 2 cubed. Yes. Okay. I'm going to do 2 more of this. Number 6. Did we all get number 5? Was able to get number 5? Okay. Number 6. Yeah, 2 cubed, yeah. That's okay. We tend to miss it. Please ask. You got me? All right. That's all I need. Okay. We have here, first parenthesis, the quantity of 7 x to the 6th, y to the 9th, all raised to the negative 2 power, times the next parenthesis, 6xy. And I believe that this is one of the questions I wrote down from my math lab. Okay. If you wanted to, 2 ways that we can look at this. The first way, this whole expression, the very first parentheses, 7x to the 6, y to the 9, raised to the negative 2 power, we can take this whole expression and take the reciprocal of the whole entire expression, okay, place it in the denominator, and then that outer exponent becomes positive. That's one way to do it. Okay? Well, I can't say which way is easy. It's just that we have to stay in the realm of the exponent properties. So what goes first is kind of up to you. There's really no certain order, but I know that we eventually want to get rid of the parentheses. That's one way. Or what you may see is taking the exponent of negative 2 and distributing the exponent to each factor. So you're saying 7 to the negative 2, x to what power?
6.
Not 6, but if we're applying to the negative 2,
Negative 12.
yes, negative 12. Y to the negative 18, and then we still have the times 6xy. So at least now we don't have any parentheses, okay? So this is where I go and I say, all right, I know I have some negative exponents, and originally the question doesn't start off as a fraction, so I know my answer, there's a possibility that my answer may end up being a fraction at the end. So I ask myself, okay, which set of factors will stay in the numerator? This is understood. If we want to, we can say all over 1, make a little invisible line. I can say it over 1 if I wanted to. But which set of factors are going to stay because the exponents are positive?
6xy.
Okay. And then we know the ones that we're going to take the reciprocal of. The base 7, the base x, the base y, with the respective exponents. So you're saying 7 squared, x to the 12, y to the 18. I'm glad we come up with this question because I want to give you a shortcut.
What you're supposed to, you got the square out there for the 7 out there. What you supposed to square that 7 to 49?
We will do it.
Oh, you haven't finished it yet?
No. You're just working ahead, I tell you. Just ahead of me. Okay, so, yes, that 7 squared will become a 49. I promise you that. But before we do that, I want to show you just quickly a shortcut where, see, a marker here. Leave that there. That x, y, all over x squared, y to the 8, x to the what, 12, y to the, I said 8, 18, okay, correction. Alright, if I didn't show you the shortcut, this would be what you would normally do. You would say x to the 1 minus 12, y to the 1 minus 18, and then you're going to have negative exponents, and then it's going to go back to the denominator. Okay, that's what's going to take place. And then you have to take the reciprocal to make it. So I'm going to show you a quick step where we can take away some of the, at least 2 steps from this, okay? Here we go. X, let's look at our base X. We have X in the numerator and we have X to the 12th in our denominator. Where do you have the greatest amount of X's? Okay. Now, because this is the quotient rule for exponents, either way we're going to subtract, but we're going to take away some steps from this. Now, this only works when the exponents are positive. You can't do it when it's negative, okay? You can't apply this shortcut when the exponents are negative. So, I know that I'm going to take away, I'm going to subtract, but where I place it depends on where I have the greatest amount of x's. So, my base x here, in the numerator, x to the first power over x to the 12th, you already said that we have the greatest amount of x's in the denominator. That's where we're going to place our x. And this is what you're saying. I'm going to subtract an x from out of x to the 12th. I have x to the 11th. So then we don't have to worry about trying to do the reciprocal. We can not to say that this isn't correct, we can just omit that step. Look at your base y. Where do you have the greatest amount of y's? That's where your answer is going to go, in the denominator. So you're going to subtract a y from out of 18. How many y's do you have? 17. Okay? So we can take away, and like I said, this only works with exponents being positive. Okay? So x out of x to the 12th, we're taking away, we have x to the 11th, y, from out of y to the 18th, we have y to the 17th. So now we will bring back our, we'll simplify 7 squared. So now we have 6 all over 7 squared, which is 49, x to the 11th, y to the 17th. Made this 6b. I said 2 more, but I want to do a shortcut here. Then we'll do, look, I want to show you the shortcut rule again. Yes, that's a 20, yes. Without having to show me the subtraction part of this, let's look at this shortcut, okay? I have our base A's and base B's. Where do you have, look at your base A, where do you have the greatest amount of A's? Numerator, that's where you're going to place your answer. So, we're going to subtract 10 A's from out of 15. How many A's do we have? 5. Look at your base B, numerator, denominator. Where do you have the greatest amount of B's? Denominator, that's where your answer is going to go. We're going to subtract 12 B's from out of 20. How many B's do we have? 8. So, A to the 5th, all over B to the 8th.